Hey, what's up, developers? I hope you're all pumped and ready to dive into another exciting challenge. Welcome to day 30 of the Dev Challenge. Can you believe we've made it this far? Time flies when you're having fun and learning new things. Today, we're tackling one of the fundamental data structures in computer science, the queue. It's a concept that's simple yet incredibly powerful. We're going to implement a simple queue using a list in Python. This will give you a solid understanding of how queues work under the hood. Let's dive right in. Get your coding environment ready because we're about to get hands-on. So what exactly is a queue? It's a linear data structure that follows a particular order in which operations are performed. Think of it like a line at the coffee shop. You wait your turn, and the first person in line gets served first. First come, first served. It's a fair system that ensures everyone gets their turn. The first person in line is the first one to get their coffee. This is a perfect analogy for understanding queues. This is known as FIFO, or first in, first out. The first element added to the queue will be the first one to be removed. All right, let's get into some code. This is where the fun begins. Fire up your favorite code editor and create a new file. Call it QPy or whatever you prefer. This will be our playground for today. Now, let's start by defining our queue class. This class will encapsulate all the functionalities of our queue. Python class queue. Here, we're initializing an empty list to store our queue items. Simple enough, right? This list will act as our container. Next, let's add methods to enqueue, dequeue, and check if the queue is empty. These methods will define the core operations of our queue. Python def is empty, self, def on queue, self, item. This method will add an item to the end of our list, def dequeue, self. This method will remove the first item in the list and return it. Our is underscore empty method checks if the queue has any items. It's a simple yet crucial check. This ensures that we don't try to dequeue from an empty queue, which would cause an error. The onQueue method adds an item to the end of the list, and the dequeue method removes the first item in the list, returning it. Easy peasy, right? Let's see it in action. This is where we put our code to the test. Create an instance of the queue and perform some operations. This will help us verify that our methods work as expected. Python if. Here we enqueue 3 items, 1, 2, and 3. This will populate our queue with some data. Then we dequeue them and print the results. This will show us the order in which items are removed. As expected, the items come out in the same order they went in. This confirms that our queue follows the FIFO principle. Finally, we check if the queue is empty. This is a good practice to ensure our queue is functioning correctly. And that's it, you've successfully implemented a queue. You've just implemented a simple queue using a list in Python. Easy, right? But don't stop here. But don't underestimate the power of queues. They are fundamental to many complex systems. They are used in a ton of applications, from task scheduling to managing resources in operating systems. Understanding queues will give you an edge in solving real-world problems. So keep practicing and keep coding. The more you practice, the better you'll get. Don't forget to smash that like button if you found this helpful, and subscribe for more Dev Challenge content. Your support keeps us going. See you in the next one. Happy coding. Keep pushing your limits and stay curious.